Okay, this is 1.3. We're on the graphing section, so you're definitely going to want a graphing calculator. And I'm just going to go through some examples together so you can see what's happening. But a log function, remember, it's a reflection. It's of the exponential function. So if I have 10 to the power of x, log base 10 of x is a reflection over that line y equals x. Okay, so we're taking our exponential function and we're reflecting it over. The x-intercept is always at 1, just like here the y-intercept is at 1. Okay, so if I want to graph log base 10, that's what this is, remember. I know that my intercept is at 1. So when x is 1, y is 0. And then it says make a table. I'm going to just bring the table over here. My next value is at 2. And I'm going to just change these. I'm going to start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is my base. So I don't care about all these other numbers. I care about my base. So when my base is 10, the x value, y is 1. So if I come all the way out here to 10, y is 1. The asymptote is that x equals 0. It never can be 0. And then it slowly is increasing. That's what a log function is. It's the slow, slow, slow increase over time. So that's why we see a lot of these functions in banking. Okay, now let's look at 3 to the power of x versus log base 3. So 3 to the power of x, remember it goes through 1. This time on an exponential, the asymptote is horizontal. It's y equals 0. When we have a log base 3, look, we're still at 1, but this time our asymptote is along the y-axis. And I'm stopping there because I want to look at the table for this. I'm not going to make a table for the exponential one because we've done those before. But for the log, the intercept is at 1. So when x is 1, y is 0. The next value that matters is when y is 1, and it's the base. So when y is 1, x is 3. That's how you can tell what base of log you're actually graphing. Okay, now let's look at some decay. So what happens when we make this a fraction? It's a decay. It's a decreasing function. We still go through at 1. So I'm graphing this one, f of x. And it's a decay, so we're going down. And this time, look at our asymptote. It stays the same. It's still y equals 0. So a log function, when we change it to decay, just want to change the 3. There we go. It flips too. So now we're going down, and I want to look at our table. What happens when x is 1/3? Y is 1. Okay, so you always want to look at that y is 1. So on our log function, when x is 1, y is 0, but when y is 1, x is the base. So our base is here, and then it goes through 1. Those points are really close here, and our asymptote stays at x equals 0. So you're going to be graphing those. You will have a graphing calculator. You'll also be looking at shifts of the function. So A out here in front is what we call stretch. The number inside the parentheses is the horizontal shift. And then the D outside, this number is our vertical shift. And then, as you know, B is the base. So whenever we have a log function, our asymptote is at x equals 0. Unless there's a horizontal shift, it's going to change. But our domain starts at that asymptote and goes out to infinity. And then our y values are never affected in a log function. They can be any value. So negative infinity to infinity. So you're going to have to identify domain and range, and then it's just going to ask you if a graph is increasing or decreasing on some of these.